Hey, this is XDF, and today we're going to talk ThemeBleed. It's a new Windows 11 exploit that is making a bit of news right now over the last few weeks, and we're going to dive into the main proof of concept out there that I've found, and talk about how it works and figure things out as we go. So let's take a look. We're going to start with a quick overview of ThemeBleed, and basically, if you have a .theme or .themepack file on Windows 11, these are meant to load up your themes, set your background, your font sizes, your font, etc. There is a vulnerability in that if you have a Themepack file, it's going to reference these MS styles files. And if you have one that's set to version 999, then it's going to make a request to read the same file _vrf.dll and try to load that. The problem is it checks the validity of that file to make sure it's signed and valid. And then it waits a little bit, and then it loads it. And during that wait time, we have a chance to swap it out and put something malicious there, so a malicious DLL gets loaded. So that's the exploit. Is we switch the DLL to time of check, time of use vulnerability. It's a race condition. So let's go check it out in GitHub here. I'm at this repo from Gabe K. This is the main POC that's out there as of today, at least. I mean, clearly there's a ThemeBleed.exe, which you can download from the releases over here. And it has three options for running. So the bottom two, make theme and make Themepack, you have to give it a host and an output path. So basically you're saying, here's my host that you're going to interact with, and here's just where I want to save the output. Here's my theme file. And these both, a Themepack is just a compressed theme with maybe some options to put more files into it, but we're not going to do that. And so these are just, both these commands are for creating a payload like that we could then just send to a target to try to get execution. The server is a little bit interesting. Why do we need a server? What are we doing that's going to involve a server? I could make guesses at that, but we will look at the code and see exactly what it's going to do. So it'll make more sense. It also has this reference to data files, which is one of the folders up here, data. The binaries in the correspond to the three files returned by the target POC. So stage one has an MS styles file with the pack theme version set to 999. Then we have an unmodified MS styles file set to pass a signature check. And then we have a DLL that'll be loaded and executed. The provided example launches calc. Now something interesting, MS styles files, I looked this up on Wikipedia. They're actually PE files or Windows executables, but they have their own signature that they use. They don't use the PE signature. I believe this, while I know this says it's an unmodified MS styles file, I believe these are actually, and at least this last one is definitely a valid Windows DLL, and I think this actually is too. And it does a true PE check to see that it's valid. But anyway, that's my understanding of this, but I'm not 100% sure on that one. It does say to create your own payload, you make a DLL with the export named verify theme version containing the code you want to run, and replace stage 3 with your newly created DLL. DLLs, dynamically linked libraries, have exported functions. So a standard executable has a main function and that runs. DLLs export all sorts of functions. You can export one function, you can export hundreds of functions. And when you load a DLL, you can then say, hey, I want to call this function from this DLL. So what it's saying here is when this _VRT DLL gets loaded, or VRF DLL gets loaded, it's going to try to call the verify theme version function. So we want to use that to put our malicious code. Cool. At this point, well, I guess we can take a quick look at the data directory. So there are three binary files here, stage 1, stage 2, stage 3. Nothing super exciting. If we download these and run like file on them, we'll see that they are all Windows executables. And not much else. They told us what this is, so we can go from there. What's interesting here is we're going to dive into the code. Let's see. And I'm actually going to start down at the bottom here. And so the first function we have is static main. Main is what's going to run when this executable runs. There's some arg checks. If there's less than one arg, we're going to call the usage, which we have up here, and we've already kind of talked about it, matches the README. Then we're going to get the command, and if the command is server, we're going to run server. If the command is make theme, we have some more args checks, and then we call create theme. And if the command is make Themepack, we have some args checks, and then we call create Themepack. All makes perfect sense so far. This is only 150 lines long, so it's not too bad. Creating a Themepack here. So what we have here is we are going to start with a temporary path. We're going to call create theme. So we actually create the theme, and then we're going to have this file called make cab. Cab files or cabinet files is a Windows kind of like a zip archive or a tar archive. So we're going to take that and we're going to make ourselves a cab of the directory, putting the newly created .theme file into it. So that's basically it. If we come up here to the create theme, here's where we start to get really interesting. Basically, they have this string right here, from here to here, is just a standard template string. We can see it's a theme exploit. We give it a display name, we give it wallpaper, tile style, wallpaper style. What gets interesting here is when we get to the path, the visual styles. The path to our visual style is going to be at 0, and now this right here is a placeholder that gets formatted, and we call the format here, with our host. So it's going to go to our host, the test share, and then it's going to try to load aero.msstyles. And then the rest of this is just sort of normal stuff. Okay, so we now have a theme file that we send to somebody. When they load it, it's going to reach out to our SMB server, looking for a test share, and it's going to try to load aero.msstyles. Now all of a sudden, oh, well, now I understand why I need a server, and it starts to make sense, right? If you're thinking about how am I going to switch these files out while the computer's doing something, it makes perfect sense that, well, if the files are located on a share I control, now I can do that. Run server is going to get into our data directory. Perfect. And it's there's a bunch of things here that I don't understand. I've never seen an NT filtered file system before. But I can just sort of take a guess at what that's going to do. It's something with a filtered file system on our share directory. It's going to set a create file filter for using this create file filter thing, which we will look at right up here, create file filter. Then we're going to create a share called test. We're going to add it. We're going to set up guest authentication, and we're going to share this over SMB and say server started. So we now have a SMB share being shared by this executable, and it's got some sort of filter file system working off of it. If we come up here, we can now take a look at this create file filter, and what it basically is going to do is when I'm trying to read a file, there's a filter in the way. So there's a filter that's going to check and make changes. And so if the path ends with MS style, then we're going to write something out to the console, basically saying client stage 1 requested, and then we're going to replace that path with the stage 1. So we're going to send them stage 1, no matter what. If they request anything from this file share that ends in .msstyles, boom, here's stage 1. Now, our stage 1, we know, is of type 999. And when that happens, some stuff's going to happen on the target computer, and it's going to reach back and say, hey, I need that same thing _vrf.dll. And so when our share gets a file request for anything that ends with _vrf.dll, it's going to do a check, and it's going to say, now this share access, am I calling the create file API, which is a really misworded API, because even when you go to open a file, you call create file. It's just saying kind of like create file handle. So if I'm calling create file API, then basically we know that means it's trying to check the signature. So we are going to return them stage 2, the validly signed thing. If it's not calling create file, maybe it's calling the load library API or something else, some other way of accessing the library, then we are going to return them our malicious DLL. And so by having this dynamic SMB server, we are going to return to them the stages that we want to return at the times we want to return it. And that's how we're going to get execution, something malicious. I think that's about it. There's a whole HackTheBox machine called Aero that recently released that takes advantage of this, where you can actually go on and exploit this yourself. And so I'm recording this as I'm going to put this in my blog post describing how to solve that. Definitely worth going to check out if you're a HackTheBox player, or if you're into that kind of thing. But even if you're not, this is a good exercise in looking through some source code and figuring out exactly how this exploit's going to work so that we can be comfortable using it. And so now we know how this exploit works. So thanks for hanging out with me today. I will talk to you next time.